Today we're going to be talking about Pythagorean's theorem. So you should have done an inquiry activity into Pythagorean's theorem already. And so this should be just covering it again and making sure everyone has the correct understanding. Before I even get into Pythagorean's theorem, I wanted to show you this really good question. So if I have x over the square root of x squared, and the question asks us to simplify it, what would we simplify it to? So my first step in simplifying this question is going to be looking at the denominator. If I have the square root of something, we don't know what it is, that is x, but I square it, those two operations cancel each other out. And I'm going to go through a sample to show you this one. So for example, if I have the square root of 4 and then I square it, well, the first step is to take the square root of 4, which is 2. I did my brackets. 2 squared is 4. So they cancel out. So it doesn't matter what's inside. If you don't believe me, try it with 16. Try it with 25. So those two are going to cancel out. So my numerator is going to stay the same. My denominator is going to become just x. Anything divided by itself is going to be equal to 1. Right? 10 divided by 10, 20 divided by 20, 400 divided by 400. All of those equal 1. So this kind of scary looking problem initially is actually just the equivalent equal to 1. And it doesn't, in this case, it doesn't even matter what x is because we're going to have the same number over the same number. I thought that was a cool question to start off with. So now we're going to go down to the doodle notes that I've posted here for OneNote for you. This again is under the tab Pythagorean's theorem. So I just want to review this with you. So Pythagorean's theorem was invented by a man named Pythagoras way back in the day, and he had a lot of time on his hands, and he was playing around with triangles, and he noticed this pattern. So specifically on a right triangle, and only right triangles, he noticed if you took the square of the two sides, which he called A and B, they would always add to the square of side C, or the hypotenuse. So specifically, let's label each of those letters. So A and B are the legs of the triangle. C is always the hypotenuse. Specifically, the hypotenuse is always the longest side. If you don't know the side length, though, that's not helpful. So it's always the longest side and the side, opposite the right angle. So literally, I can draw an arrow. Side C is opposite that 90-degree corner. So let's go through these examples. Label C. So C is always our hypotenuse. So here's my 90 degrees. Move. That's going to be C. 90 degrees. C. Remember, in math, diagrams are never drawn to scale. We make that assumption always in mathematics. And so that knowing the 90 degrees is the most helpful piece. In these next examples, circle the number that's the hypotenuse. So remember, the hypotenuse is always the longest side. Therefore, we're looking for the largest number. So this would be 75, 39, and 85. Okay, let's do some problems here. So find the missing links. So when we do anything with Pythagorean's theorem, it's really important to show your work. And when we're showing our work, we need to do it in a certain way. So in math, we always have certain kind of expectations with our work. So the first step is always to write our formula down. So our formula is a squared plus b squared equals c squared. A helpful tip is let's label those sides. So this I'm going to choose to be a, and this I'm going to choose to be b. So now let's fill in the blanks. So a is 10, so it's going to be 10 squared. B is 20 squared, and then c is my unknown. This next step is a step that kids often forget about. So this is a big step. Actually square them. So 10 squared is 100. 20 squared is 400. 100 plus 400 equals 500. Okay, so this is great. 500 equals c squared, but I want to know what just c is. So how do I cancel out that squared? we square root it. Those are really important pieces. So on your calculator, sometimes calculators do this differently, so you'll have to play with your calculator here. Sometimes you'll put in the 500 and then square root. Sometimes you'll press the square root button and then the 500. So I'm going to be left with C on the right side. This said to the nearest tenth. So I get 22.4 is our value for C. Okay, let's try this next one. So in this next one, 100 is my side C because it's opposite that 90 degrees. 60 I'm going to call A, and B is my unknown side. So in this one, we start off by writing our formula. I'm going to plug in the steps I know. So 60 is A, B I don't know, so I'm going to leave it as B, and C is 100. So these are some big numbers, but that's okay. So 60 squared, let's do a shortcut here. I know 6 squared is 36. So then I'm going to toss in 2 zeros because the 0 on 60 is squared. Plus B squared equals 100. So 100 squared, I know 1 squared is still 1. So 100, then I have those 2 zeros I have to deal with. When I square the 2 zeros, they're going to become 4 zeros, giving me 10,000. Okay, now let's go back to our algebra. I need to isolate and solve for B. So I first have to cancel out that 3,600. So it's currently positive, so I'm going to subtract 3,600 from both sides. So I'm left only with B squared, and then I have 6,400. I want just B. I don't care what B squared is. I need to know what just B is. So I'm going to take the square root of both sides. When I do that, I get 80. Let's do a pause here and check. We want to make sure we didn't find the hypotenuse on this one. So we know our number should not be the largest number. 80 is less than 100. So we know we're in the clear. So there's 2 examples there on Pythagorean's theorem. I hope that made sense. And this is a theorem you're going to use for the next at least 4 years in school. Pythagorean's theorem comes up in grades 9, 10, 11, and 12. This is probably the most important theorem you're going to see in mathematics in high school.